in Jordan. طبعا أنا حابب في البداية إنه نشكركم جميعا، نشكر نقابة المهندسين الأردنية طبعا اللي هي شعبة الهندسة المدنية أتوقع المياه والبيئة، يعني خلينا نحكي على تنظيمهم لهي الورشة بالتعاون مع الجامعة الأردنية. طبعا احنا بنحاول من خلال هذا المشروع اللي هو طبعا انه مشروع اوروبي، انه وفعلا انه تكنولوجيا جديده وبلشوا يطبقوها في اوروبا، انه يتم نقلها عندنا للاردن بصراحه لمختلف القطاعات، وخاصه احنا في عندنا في الاردن بتعرفوا مشاكل في موضوع المياه. يعني احنا اذا بنطلع يعني احنا بهمنا كمان بهذا الورشه يكون عندنا معظم الستيك هولدرز بصراحه يكونوا موجودين معنا، وبحيث انه يصير في عندنا طبعا انه شويه تعاون بيننا وبينهم، وخاصه زي ما حكيت انه احنا في موضوع الووتر يوز افشنسي، الكواليتي، اليوز اوف نون كونفنشنال ووتر ريسورسز. وبرضه يعني بيكون احد اهداف المشروع انه برضه انه الفكره تاعته انها تحاول انه يصير في طبعا انه الباك والبرودكت، انه يعني لانه احنا بنحاول انه الفكره هاي انه يتم تعميمها على مختلف البلديات والمحافظات في المملكه. يعني انا بجوز انا اطلب من الاخوان انهم يعملوا ميوت للميكروفون على اساس بس الشخص اللي بيتكلم يكون ايش الميكروفون عنده. طبعا بس ممكن الهوست يعمل اتوقع ميوت، يعني انه الله يسلمك مهندس فرح. طبعا احنا راح يكون في عندنا change the urban water management practice by means of innovative, sustainable and low cost treatment technologies. ممكن نطلب بس من الناس يعملوا ميوت من المشاركين.
بس دكتور احمد عشان الصوت راح اعمل ميوت هون، وبعدين انت من
عندك ممكن من عندك تعمل ميوت ولا تسلم استاذ ابراهيم معنا. يعني هو السيد
هلا دكتور احمد بس اعمل ان ميوت من عندك.
السيد ابراهيم من نقابه المهندسين، كل الشكر له على تنظيمه لهي الورشه، انا حابب برضه انه نشكره في البدايه. وفي عندنا برضه انه من اهداف المشروع انه replace the use of portable water with the good quality of non-conventional water, increase the adaptation of innovative, sustainable and low-cost technologies, and measure for the use of non-conventional water resources for domestic purposes. اللي بعدها الصراحة يعني احنا زي ما حكيت راح يكون في معنا خلينا نحكي شركتنا في المشروع بايطاليا، خلينا نحكي الدكتوره باربرا، هي من سيسيلي في جنوب ايطاليا، وراح تعطينا هي فكره كامله عن طبعا، واحنا راح نحاول نطبق في المرحله الاولى. عندنا راح يكون في عندنا 2 بايلوتس، راح يكون عندنا في بلديه جرش تم اختيار احد المساجد مع مركز زهد الثقافي، بالاضافه طبعا عندنا داخل الجامعه الاردنيه في عندنا سكن الزهراء والاندلس. فان شاء الله يعني بيكون انه فعلا النتائج اللي نطلع فيها يتم تعميمها على مختلف خلينا نحكي الجهات المعنيه في المملكه، وبالتالي يعني ممكن يتم الاستفاده منها. Now I want to switch to English because I want to introduce the next speakers that she will speak about the projects, nature-based solutions for domestic water use in Mediterranean countries. We have Dr. Barbara Sanari. She is also from Italy. And Barbara, if you are ready, so please you can start.
Okay, good evening to everybody. I will try to share presentation contemporary. Let me know. Can you see my presentation?
Yeah, we do.
Okay, thank you very much. So I'm Barbara Sarnari. I'm Vice President of SVIMED, and let me introduce quickly SVIMED. Okay. SVIMED is a non-profit association and a group actually of 5 women. And I'm proud about this. The since 2003, we work at the European level with many projects, about 20 until now. And we try to support the public authorities to develop a sustainable process, have in mind a wider approach, so a Mediterranean approach, but try to impact at local level. What we do normally in our association is what we try also to transfer, drafting or developing a project. So the same approach you will find also in the project. Go to inside the NAWAMED project. NAWAMED is, as Professor Ahmed, that I will thank you for the invitation, tell to you is the full name is Natural Bed Solution for Domestic Water Reuse in Mediterranean country. So it's clear that we will focus the urban level, different from other projects that normally are developed about reuse. We try to focus really on the impact that we have on at the urban level. The partnership is composed by Latina Province, that is the partner of the project, Iridra, and Fabio Masi will talk after me about the technical issues of the project, because in particular they are responsible of the technical tasks related to the design and implementation of the pilot action. Ourselves, so SVIMED, that the full name is Euro-Mediterranean Center for the Sustainable Development, that we are in charge in particular of all the communication related activities. In Malta, we find the Energy Water Agency. In Tunisia, the Center for the Research for Water Research and Technology. Latifa, if I so well, is with us. The University of Jordan, for sure. That's so who is hosting this workshop, this very great workshop today. And the American University of Beirut in Lebanon. We have also 4 associate partners that normally are the municipality where the pilot installation will be done. So the municipality of Tunis in Tunisia, municipality of Ferla in Sicily, so in Italy, and the municipality of Jerash in Jordan, and also the Polytechnic of Turin that will support with the technical related issues, because they are facing also this kind of challenge. The budget of the project is about 3 million euro. It is financed 90% by the EU contribution. The project duration is 36 months, and now we are more or less in the beginning of the second year. And go inside a little the program. It's a very interesting program for us because put together 14 EU and partner countries trying to foster fair, equitable and sustainable development on both sides on the EU external borders. The program is based on 4 thematic objectives and 11 priorities, and in particular NAWAMED project will contribute to the thematic 4, so environmental protection, climate change, adaptation and mitigation. Inside with the same thematic priority, other projects on water management are financed mainly on agriculture related issues, so reuse in agriculture. Only NAWAMED project and another project named Equacycle that I will quickly explain later, will try to face this urban level. In fact, the NAWAMED general objective of NAWAMED is to change the urban water management practice by means of innovative, sustainable, and low-cost treatment technology, so nature-based solution applicable in a decentralized way to replace the use of potable water with good quality of non-conventional water. If we want to try to have a wider vision of the initial needs and the future objective, we can say that the standard water management system is linear. So we put together each kind of wastewater, I mean rainwater, grey water, black water. We mix all this kind of water and normally are after treated all together in a centralized way in a plant that sometimes in Italy, in Sicily mainly, we have problem of that are overlooked by this kind of management. And in this way, we are not able to take advantage from the non-conventional water that normally are not so polluted and easily treated to be reused. So what our final objective, that obviously now is just a part of this, is to try to make more circular all this process, trying to reuse directly on the building at the urban level the non-conventional water easily not so polluted, so as the green water or the rainwater. And in particular, what we will try to demonstrate and to make with the NAWAMED project is to reduce the use of potable water for secondary reuse and supply at the project level about 9,000 cubic meter per year of non-conventional water that can be used, reducing the use of potable water. In fact, the specific objective is to demonstrate the technical and economic feasibility of nature-based and low-cost solution to treat and use non-conventional water resource in school, for example, university, public facilities, or as will happen in Lebanon in a refugee camp. In this way, the recovered wastewater and stormwater will be reused for different purposes, including, for example, toilet flushing or irrigation, and therefore consumption of potable water for domestic use will be decreased. In general, so we can say that we will try to demonstrate that design architecture can make a building an efficient water producer rather than a water consumer. How we can reach this goal, actually further than the 8 planned real-scale pilot installation, so in Tunisia, Italy, Lebanon, and Jordan, we will develop also a technical visit. We hope also during the installation of the pilots, not only at the end, but it depends from the pandemic period, training workshop at technical level, but also we will try to involve from the beginning also decision makers by workshop and during water tables that will involve both technical and political level and all key stakeholders in a participatory process that aim to boost new policies for reaching a more sustainable water management. So we are not involving only the owner managers of the 8 pilot sites, but also engineers, architects, construction companies, university students, staff of local and regional authorities. In particular, the process that will involve policies is very important because we have to imagine that always a project alone cannot change really policies, can contribute to do this. It is important in this sense that the projects not only work together during the time, so the continuity and to be consistent in this process, but to also try to be included in a process that with communication and networking between stakeholders, between other projects ongoing, will try to foster the national regional strategy, able to integrate in a long-term perspective the project results. In this sense, during our project, is planned to develop this water table at local regional level to reach 6 final local regional strategic documents. But the feedback of these water tables will be make us able also to debate the same issues also at the Mediterranean level and finalize a unique Mediterranean policy document to foster the inclusion of water demand management and non-conventional water resource measures at the regional and national policy framework. This is very important because it's important to have a wider strategy and after to try to reach the local impact. In this sense, NAWAMED is also working to capitalize past experience and to cluster with other projects. For example, a project that we will capitalize that involved already some partners of NAWAMED, particularly Hydra, ourselves, VMED, but also the Tunisian and Maltese partner, is SWMED, that was financed in the past programming period, always on the MPCBC Med, and was useful to a theoretical level to study with a multi-criteria analysis and developed some case studies and some water tables. Again, we capitalize this approach to reach some local impacts. For example, in Sicily, in Ragusa in particular, that was the pilot city, we were able to integrate in the building code of the municipality some indication to foster the use of non-conventional water at domestic level, and so the construction of the installation of decentralized system as the wetland constructed system. Again, in a project that we just closed at the beginning of this year, in another project that was about tourism management. So it's important also to understand, in the case of natural-based solution, the holistic approach. We installed this green wall that you can see here in a beach resort to reuse the water of the shower for the toilets or for the garden, because green wall in particular can improve aesthetic, regulate temperature, and enhance biodiversity and air quality. So it's very important, for example, in the case of natural-based solution, to have this multi-sectoral approach and involve different stakeholders, because normally we find many projects on natural-based solution about energy efficiency or biodiversity or air quality, but it's important also to try to integrate all these sectors and reach a global vision to really enhance the impact of the results. How I was saying, we are developing also clustering activities, for example, with AquaCycle, that other project in the same priority of the program, that is working to demonstrate an innovative technological solution for water management at domestic level. And so we will try with them to organize activities, to share information, and also to put in contact partners. So this kind of collaboration that actually we are developing at Mediterranean level is also useful at local, regional, and national level. And for this reason, each contribution is welcome, and the call to action is to join our force to boost the use of non-conventional water and to invest in natural-based solutions. I hope in this brief presentation to to have bring to you, get to you the heart of the project. I avoided to explain each activities because I think that if you are interested, you can discover with asking to us, visiting the website, or contacting directly the partners, in particular the University of Jordan, the activities. And please follow us by the website, by Twitter, and subscribe the newsletter. And for any question, don't hesitate to ask to us. Thank you.
Thank you so much, Barbara. Hi, how are you?
Thank you, Farah.
Thank you so much. First of all, I will take this opportunity to thank Professor Ahmed Salami and Engineer Sura for this invitation. Actually, I'm so glad to be with you today. Actually, you always impress me with your clear, quiet explanations. So you are great, Barbara, as usual. Actually, your project is very important, especially for us in Jordan, because as you know, we are suffering from the scarcity of water. So I think from your project, our Jordanian partner will learn the best practices to how to reuse the water to be source, for example, for irrigation and so on. So thank you so much. And for me, I will just be available for you for any question or support. Thank you so much.
Thank you, Farah.
Thank you very much, Dr. Barbara. Now I will leave the floor to Mr. Fabio Massi to present.
Many thanks, Sura. I'm just going to share my screen. So good evening or late afternoon, everybody.
Good afternoon.
Is it coming? I hope yes. Do you see my presentation?
Yes.
Just disappeared where I can, yeah, I got, sorry. Okay. So yes, good evening, everyone. My role this afternoon is just to update you about the technologies implementation, so namely the pilot sites that we are going to in the project. First of all, who I am Fabio Masi, so a chemist, a PhD in environmental sciences, which is meaning that I'm dealing since more than 30 years with pollution and environmental pollution, let's say, trying to clean it. And since almost 25 years, I'm dealing exactly with a kind of cleaning which is linked to natural functions, so the ecosystem services that we can find in nature. When we talk about wastewater treatment and so on, we are most of the time talking about biological treatments, and that's exactly what I started studying during my PhD. And since that time, we started setting up a team. So in '98, IRIDRA was funded, and we started designing constructed wetlands, which are just a kind of reactor where bacteria, biofilm, is the main actor in removing pollutants. In the history, therefore, in our history, since 2000, 2 years after IRIDRA was born, we started making research, which was how to find new applications of what we call nowadays nature-based solutions, which is all the group of technologies that have normally quite a low cost in terms of management mainly. Even the investment cost is not so relevantly higher in comparison to other more compact and energy needing technologies. And in all these nature-based solutions are this tool of whatever is making use of natural ecosystem services for providing services which are useful to we humans. In all our process, so we started finding several applications, industrial applications, diffuse pollution and so on. And just in 2003, 2004, our first project was with the AC, was just linked to the touristic sector and the applications of nature-based solutions in that sector. And that's exactly when we started talking about gray water, which is quite a nice kind of wastewater from the point of view of me as a chemist, because the gray water is more lightly polluted in comparison to the black water, which is the one transporting the fecal matter and all our excreta, let's say urine and fecal matter. So the gray water is only coming from sinks, showers, and whatever is not connected to the toilet itself. And so the gray water is about the most abundant effluent from a house. It's about the 70% in Europe, even in North America. So it's really quite a big, considerable amount of water, considering that the consumption per day is over 100 liters normally. And therefore, we are still talking about several tens of liters per day that you can recover. The kind of pollution that is inside is even, sorry? Yeah, sorry. The kind of pollution that is contained in the grey water is also... Sorry, you have to mute your mic. I don't know who, or who has the control to please mute it. So there are several advantages because the kind of organic molecules which are contained in the grey water are much faster in degradation in comparison to the ones which are contained in the black water. So treating grey water is easier, and that can be really a very nice sector of application for nature-based solutions. So as Barbara has shown before in this sketch that we designed, we can make use of several units which can go in ground-based solutions. Those are for sure the best known. This constructed wetland technology is nowadays a 50 years old technology. There is a lot of background. And so the ground-based solutions that are exactly these ones are for sure the better known and the most economic in terms of realization and even operation and management. But for instance, we were working in India and there was no way to get square meters, free available square meters on the ground. And so we started thinking, well, is this meaning that we have to work with membrane bioreactors and sequential batch reactor and so on in the cellars, or do we still want to make the city more green and to have a lot of other side benefits and to still make use of nature-based solutions? Yes, we want to go there, but how? And the way was just to make use of unused surfaces. And these unused surfaces were not on the ground. They were on the roofs and on the walls. And so we started studying this kind of installations like green on the roofs and green on the walls. And that's what we are still studying nowadays, even in this project. So exactly in this project, the pilot sites are exactly the ones which are listed here in this table. So we plan to get at the end about 9,000 cubic meters per year of effluents treated in order to be then reused. So that's what we are gaining and saving from the aqueducts, let's say. The flows are reported here. So we are still talking about 1,000 of cubic meters in each country. Lebanon is has the highest amount, but Jordan is immediately following. And here we have the name of the sites that Barbara already presented before. And for each site, we have already quite precise ideas, if not designs already done. And so when the designs have been already done, we already have also a precise estimated cost of the infrastructures in terms of realization cost. So in all these kind of installations, we are playing a lot with constructed wetlands, ground-based, with green walls, and the rooftop wetlands. And so for the green walls, for instance, we are thinking to them exactly because in a lot of situations in the urban structure, we don't have enough room for ground installations. And therefore, it's just a need of space, let's say, of surfaces where to locate our treatment units. But more than this, we can even think to add some beds. And that's a quite characteristic aspect of designing nature-based solutions. Since almost 30 years, we are stressing the concept that it's very good to have multidisciplinary teams when you're dealing with this kind of technologies, because you are biomimicking nature. So you are trying to replicate whatever is happening in nature, which is a quite complex reactor, let's say. So it's quite difficult to understand exactly the degradation pathways of all the single molecules in a reactor where you don't have only few elements that you can consider, but you have multiple ones. You have a complete food chain, for instance, in a nature-based reactor. Which is meaning we have the bacteria, the protozoa, and the animals eating the protozoa, and so on. So you really have a lot of effects which are not so easily understandable, but nowadays with the knowledge we have developed in some of these nature-based solutions, we are almost able to model by engineering models, so to use equations to understand how our reactors will behave immediately and in the time. So their evolution in the time, their aging and so on. So we now know quite a lot. And it's very good if you do all this, putting together different disciplines. I mean, it's nice that engineers, chemists, and biologists can play with models and understand how the nature-based solution will perform in terms of removal and so on. But it's even nice if designing a landscaping architect can put her hands or his hands on the design and make it much nicer in order to be more socially accepted and better inserted in the city. And then maybe there is another engineer which is specialized in thermal insulation that can put his inputs in design for getting another effect, which is the energy saving. So the creation of nexuses, so of links, in between the different fields, which are energy, water, and maybe even food, is exactly the solutions for the future that we are aiming to. So that's exactly what the kind of functions that we are looking in a green wall, which are as side benefits, for instance, a sort of effect on the air pollution. And then we have even photosynthesis, so production of oxygen, absorption, which is a temporary storage of CO2, and that's even another good effect because we are storing CO2 and removing it from the atmosphere. And then if we are creating insulation, we get a reduction in energy consumption, and even creating a more efficient evapotranspiration in the area, which is then creating some microclimate effects, contrasting, for instance, the heat islands in the cities. So we could even have a urban planning where we are going to install centralized green walls for recycling, let's say at block level instead of house level, if we have observed in that part of the city the recurrency of heat islands in the time. And therefore, one way to make cities more resilient is just to understand where these kind of phenomena are going to happen or are already taking place, and then to install countermeasures like green infrastructures for mitigating these worst effects. And obviously we are inserting green, so we are creating biodiversity. For instance, bees, and the bees are a big issue at the moment. They are dying a lot by the pesticides, so it's very good to create safe environments for them. And then we can make use of these insulations even for insulating by the noise. And all these obviously will increase the building longevity because we are creating another parallel wall. And all these can create a nice aesthetic in the city. And for instance, there are quite recent British studies that are saying that enjoying the green is creating health. I mean, people is getting less sick if they spend time like 1 hour per day walking in the green or looking at the green. So there is a good correlation. We can even save money, let's say, in terms of public expenses of the health system, installing more green in the cities, because it's now proven by science that the good effects are taking place. In all this, we wanted to know, well, can even treat wastewater in all this? Because the installation of a lot of these green infrastructures in the city is needing water. Do you want to irrigate them with tap water? No, we want to make instead the production of a new source of water in the city. That is exactly the treatment of the water. So if another function could be just to diffuse Wi-Fi everywhere, I'm sure that in 5 years maximum with Chinese timing, we could have everywhere in the world a lot of green walls treating greywater. Unluckily, we are still not able to do this, but we are working on that. And so the process will be probably slower, but I'm joking, but just consider that if every house could install one of these green walls, we would save a lot of water, and that could be really a green economy new sector, a new market, because still there is a lot to develop and a lot to play in this sector. Just a few years ago, we made some research with the University of Torino, Polytechnic of Torino. So that was the Super Green project. If you look at our Facebook page of Iridra, just yesterday, most of the results, practical results, I mean numbers, figures obtained in this project have been published. It's an open access paper, so you can download, make citations and so on. So everything is reported there, and what we discovered is anyway that we can charge much we can charge the systems, still having good performances, that we have been able to reach the reuse limits in Italy, which have, I would say, the worst regulation about reuse of the planet at the moment, because it's very stringent, too much stringent, and just not making differences in between the different kinds of reuse. But in all this, the only thing that the green walls are not able to do with the grey water is to get a complete disinfection, the kind of usage of reuse is still limited by this. I mean, if we don't want to add any other treatment, we will not be able to make noble usages of this effluent. But otherwise, instead, we can easily flush the toilet, for instance, even for the Italian regulation, and go further with landscaping or irrigation of green areas. Obviously, we made even a research of the social acceptance of these kind of schemes. And what we discovered, for instance, is that mixing all the treated effluents when we operate at block level or apartments which are close one to the other, or even, well, one floor over the other, is much better, is more socially accepted to mix all the effluent and then pump it back to the apartments, instead of having a defined source like who is living up floor is giving the water to the ones living in the apartment below. But well, in what we discovered, and that was in India, was anyway that this kind of technology was not having big issues in terms of social acceptance. I hope it will be the same for the installations we are going to have also in this now project. So just for giving you a flash of what we are doing, in Ferla, in Sicily, there is a school which will have a green wall and a green facade. A green facade is just it's exactly like a green wall, but it has a self-standing structure where some climbing plants are growing. So the plants are still planted on the ground. Yes, I have a few minutes more.
Okay, so if you maybe, because we'll have discussion after the other presentation, so hopefully that
it will be very fast.
It can be finished soon.
Yeah, I've just these sketches. So in Latina, we will have a horizontal, which is a ground-based constructed wetland. That's the most simple technology for treating the gray water. In Lebanon, 3 pilots. One will be a green wall, and then a horizontal flow constructed wetland. And a nice example will be this one on the bottom, which will be a portable nature-based solution. So it will be contained in a container, and it's a quite compact and efficient constructed wetland, which has some aeration on the bottom, which is making it much more efficient. Let's say, yeah, it's consuming energy, but then it's more efficient. That's the system we have designed, and it's nowadays going to be realized in Tunisia at Sirte demonstration site. What you can see here is that we can install green walls even in self-standing structures, creating in this way some landscaping design. And what we have in Jordan are exactly these 3 technologies, the green facades, the roof wetland, and the green wall. So those are the daily flows that will be treated and then reused, mainly in the toilets for flushing. It's the dormitory of the university. And so that's exactly the design that has been already made of the green facade. You see here that is a self-standing structure, so the plants are not putting their roots directly in the wall. And then we have also the anchored green wall. Here the water is instead flowing inside these pots. In the former one, the water was staying just at the ground level. And that's the roof wetland, which is an installation over the roof. Obviously, this one is have to be tilted 90 degrees. So it's a sand layer where bacteria are living, which is filtering the water, and it's exactly the same in the green walls also. Still in Jarash municipality and the Za Cultural Center Park, the 4 scene technologies are both green walls and green facades. Still, the design here have to start, so I have not much more to add. And with this, and 4 minutes, 2 minutes of delay, I'm ending up. Many thanks. ready for available for every kind of casting.
Thank you so much, Dr. Fabio. Next, Prof. Radwan Lushah from the University of Jordan will talk about non-revenue water management in Amman, a case study of Yaduda area. Welcome, Prof. Al-Lushah.
Good evening, everybody. I think it's evening everywhere. Dear colleagues, I'm here representing both the University of Jordan and the Jordan Engineers Association, as I'm an elected member in the civil section of the Jordan Engineers Association.
Hello. Allah Akbar. Allah Akbar.
What I ate was like a.
Is there any hacker in the meeting?
No, Arij Adnan.
I don't know what happened, bro. I'm sorry, bro. Oh, this is cooler.
Okay.
Who's that?
Now I will, let me see if I can see how to maximize my screen here. There is view, okay. Screen.
If you go below, in the bar below, on the bottom, yes, it's just on the right there. Yes.
Yeah, okay, but because I used to have it from screen. Now I'll be talking about non-revenue water management.
يعني أقدمك دكتور، إذا تسمح لي أقدمك بس.
تفضل.
طبعا هلا في معنا الأستاذ دكتور رضوان وشاح. الأستاذ دكتور رضوان وشاح هو عميد كلية عميد البحث العلمي، عمادة البحث العلمي في الجامعة الأردنية، وهو برضه إنه عضو شعبة الهندسة المدنية في نقابة المهندسين، وعضو مشروع برضه نوامد. فهو يعني هون على 3 جهات، واستاذ برضه المياه في الجامعة الأردنية. فراح يكون عندنا هلا في المحاضرة. تفضل دكتور رضوان.
شكرا دكتور أحمد. شكرا my colleagues at NAWAMED, and it's a pleasure to be part of this team. We will talk here about non-revenue water management in Amman, a case study of Yaduda area. As you see, non-revenue water is defined as the difference between water produced and water bill that is retained. And this non-revenue water can be divided. It's a major problem in Jordan. As on average, Jordan, non-revenue water in Jordan can reach 50% most of the times in most areas. As you see, the study area is Yaduda. I have to be fast because I have a master thesis discussion in about, supposed to be at 6, so I postponed them 10 minutes. So I have to finish in 10 minutes. You have to pardon my quick slides. The aim of this project is to reduce non-revenue water in this distribution zone. We call it Yaduda. Yaduda is part of Amman. It's south of Amman. It has intermittent water supply with an area of 36.5 square kilometers. Now we have to assist in this project. We want to assist the existing non-revenue water, and we have to quantify the real losses and apparent losses in Yaduda distribution network, and we have to recommend non-revenue water management for this pilot area, and this can be extended to other parts of Amman. Our methodology includes data collection for different water supply sources in the study area, analysis and modeling of non-revenue water using a software developed by Bentley, which is called Water Gems, which is a water CAD, and combined with GIS system, analysis modeling of using the International Water Association tools, namely the AWWA spreadsheet, and we have to test several options to reduce non-revenue water, and at the end we have to develop guidelines for best management practices to help the decision maker in reducing and managing non-revenue water. In the modeling system, we have main sources. We have to define the elements of the system, which are reservoirs, pumps, towers. We have to also identify the elements of the network, which is main connection valves, pressure reducing valve. They are all in a shapefile. We have to have the borders of the area, because you have to isolate the area so that you can manage the non-revenue water and quantify it. And we have to identify the number of customers within this zone and what are the demands and the topography of the region, because this is part of the data needed for the model. This is just further explanation of non-revenue water. You can see that non-revenue water include water losses, which is a real losses. In Jordan, it's about 20%. We have an apparent losses, which include unauthorized consumption or metering errors. And we have unbilled authorized consumption. So this is, for example, for some public parks or some areas that they don't have billing system. The total of these elements is the non-revenue water. And you can see the small part on the top is the revenue water, which is billed and paid back to the water authority. We have also to identify the economics of several interventions and options that will enhance the reduction of the non-revenue water, taking into account the other options. Let me go first to the results. These are part of the survey that we have in zone 33. We have divided this zone into 8 networks. It was divided originally into 8 networks. And this data shows the water leaks for years 2017 and 2018, pipe blockage, house connection failure, and main pipe failure. You can see that we have a very high number of failures within the system. And we have identified and classified the water leaks per pipe diameter and pipe material. You can see that most of the pipe breakage is within the less than 2 inches to 1/2 inch of diameter. These are mostly in the house connection area or in the minor streets. The mains are not, don't have major. Luckily, the failure in these does not have a big loss compared to loss in big pipes. Also, we've seen that polyethylene pipes have the highest complaints and break within the system. Although it has been recently used, ductile iron, steel, and galvanized iron has been used for tens of years, but the failure rate is less than the polyethylene pipe, the PE pipe. Originally, as I told you, the zone was divided into 8 hydraulic districts, A, B, C to H, and fed by Duda Reservoir and Tower. We modeled that. Then we have done intervention by adding 2 different zones. So make the 10 zones, because zoning it means that you have, by introducing pressure reducing valves, mean that you can play with the pressure and reduce the leakage in the system. This is the 10 zones characteristics, how many customers and the area of each subzones. In the hydraulic model, as I told you, we use water gems. We have entered all the data needed for this model, hydraulic data, topographic data, demand data, and we can see that at the end, if we have the baseline, which is the 8th zone, we have we can in the baseline we have hydraulic. In the original, the leakage was higher; it was in the 50s. If we do our intervention by hydraulic isolation of 10 zones, the non-revenue water percent was reduced to 36%. If we add water metering replacement, this they have replaced about 1,000 mechanical water meter to ultrasonic meter, which is more sensitive to low flow. The non-revenue water was reduced to 27%. And if we just do a rehabilitation and leak detection, this is a visual inspection for breaking line illegal use, it can be reduced to 25%, 24.6%, which is the target of the Miyahuna, or the water distributor in Amman, by 2025. This is a water balance, flow balance. For that, we use the AWWA spreadsheet as auditing sheet for the zones. And a further intervention was done by redefining zones E, which is problematic area, into 4 additional zones. And we have introduced a 150 millimeter PE pipe as a main feeder to E3, and the new water meters were added to E1 and E4. These are the problematic zone where we have the ease zone, which is the high pressure zone. And we noticed that according to water balance, we have supply for this DZ30. We have supplied them with 2.9 million cubic meter, and what was paid for 1.78. So non-revenue water accordingly was 26.1 in 2018. As it was afraid that the model shows almost 46% of water losses are real losses, while the other 56%, these are part of the non-revenue water, where apparent losses means to illegal connection and errors in metering. This sheet is the AWW water audit software that we used in water systems, so that we can identify the non-revenue water, and also it can quantify the annual losses, real losses in currency and in economic terms. This is a summary of what we have said before in the model. In conclusion, I think for the baseline, as you have seen, the non-revenue water was 36.3%, and it was decreased to 24.6 at the end of this 2017. And after rehabilitation work, then increase. You know, this is by the way a USAID project. They have reduced, and it was increased to 40 to 50% at the beginning of 2019. This is because they were not able to isolate the whole zone. If you don't isolate the whole, if you introduce a new system without isolating the old system from the new system, then your system are mixed together, and this will increase definitely the non-revenue water. Of course, the model was developed, and let me go to the final conclusion. The non-revenue water, it was about 750 million cubic meter per year. It can free, and part of this, as said, it was 2/3 of this losses was real losses, leakage, whereas 36 was apparent losses. The component analysis, and that shows that the main pipe are, total annual reported losses were very minor compared to the surface connection. the estimated cost for implementation of alternative pressure management policy to reduce the pressure from 5 bar to 5 bar instead of 8 bar was $4 million. The simple payback period for this implementing this project is about 2.7 years. In fact, pressure management seems to be very powerful in reducing non-revenue water, especially in hilly areas like Amman. I think also it's recommended to, instead of rehabilitating the entire network, is to apply systematic pipe replacement, and it's recommended to increase the accuracy of meter and billing system through other districts which apply to automatic metering, reading, and now Miyahuna, which is the water authority, that the water company, service company that provide water to Jordan, are working on this in most of Amman area. Thank you very much for your kind attention. And again, I'm sorry for my fast.
شكرا دكتور رضوان. Thank you. In fact, we have like a discussion sessions at 6:30, but you will be not with us. So if you have now a few minutes, maybe we can open questions for your presentation.
Okay. I have space for 2 minutes to 3 minutes for the discussion, for questions.
Okay, if any participant has a question to Dr. Radwan, Professor Radwan, because he will be not with us in the discussion sessions.
Good evening, Dr. Radwan.
Good evening.
Muhammad Faris with you, technical consultant engineer. Just I want to ask you regarding the complaints. I think it is very strange to get more complaints in the polyethylene pipes comparing to the GI. Is there any reason behind that?
Yes, I think we have the same problem in the city of Salt, where I am from now. They installed in 2000, they installed the BE system in Salt, and they start a lot of complaints. In fact, we have now oases inside the streets because of this leakage. I think it's the problem with the joints, the problem of the settlement in the pipeline itself. You know, when you have settlement in the pipeline, although the plastic pipe is flexible, the joints are susceptible to breakage and leakage more than but we don't have concrete steel pipes, because the steel pipe have rigidity that can maintain its position. So this is one reason. The other reason is that all the new areas are served by polyethylene, so it's expected that it serves more people, and you know, you expect with more people you have to have more complaints.
Okay, thank you.
Shukran.
Any other questions?
Okay, if we don't have other questions, so maybe we can, I would like to thank Professor Radwan again for his nice presentation. And I think that we can switch now to Professor Abbas Al-Omari. Professor Abbas Al-Omari, he is a senior researcher at the Water Energy Environment Center at the University of Jordan. He is a professor of civil engineering, and also he is a team member of NOAMED project. He has many projects and many research publications in the field of water, grey water. I remember the last projects that he was working about Zarka River and etc. So now, Professor Abbas, you can start your presentation, please.
Yeah, thank you, Dr. Ahmed. Let me share my screen. Okay. Yeah, you can see my screen.
Yeah.
Yes, we can.
Okay. So I will talk. Good evening, everybody. So I will be talking about Zarqa River. I will be talking about the pollution sources to the river and their impact on the river quality. So this is the study area. This is Amman Zarqa Basin or Zarqa River Basin. The blue line, this is the Zarqa River, this one. Now this is the King Abdullah Canal. Now Zarqa River water is used for irrigation. It's a main source of irrigation water in Jordan. It is used for irrigation in the basin upstream of Temporal Dam here. This is Temporal Dam downstream of the river. And it's also used for unrestricted irrigation in the Jordan Valley. So this is, I would like to talk about the irrigation system between Amman Zarqa Basin and the Jordan Valley Basin. So the Zarqa River flows from within the basin, and this water is stored behind Temporal Dam, and then the water flows to the Jordan Valley. Now here there is a big wastewater treatment plant, which is a Samra wastewater treatment plant, which treats about now its effluent is estimated at about 250,000 MCM. 250,000 MCM per day. And now its water is mixed with Zarqa River and it goes to the Jordan Valley. Now this is the river. Now the Zarqa River actually has undergone a dramatic environmental degradation. It used to be actually a real river in the past, maybe in the 50s and before in the 60s, but now it's almost dry, and it's a creek that flows only during winter. It does not flow during summer. It only flows during winter after rainfall events. So the objective of my work or of this work is to identify pollution sources to the river, to Zarqa River, identify and quantify pollutants from each source, and also to observe and measure river flow and assess the impact of the pollutants on the river water quality and its use. So the methodology, river survey. So we first started with the river survey, and also we collected data, quality data about the river. We have two sources from existing data. One is from the Environmental Monitoring and Research Central Unit. This is IMARCO, this is NDRSS, the Royal Scientific Society, and also from the Water Authority of Jordan. So these are the two main sources of data. And another source is we did grab sampling at certain locations. And also then the data was analyzed and the conclusions made. So now the field survey, the river was divided into 6 sections. This is the river. So the river this is the upstream here. The upstream is in Ras Al Ain. For those who are familiar with Amman area and the river, the upstream is in Ras Al Ain, and the downstream is at Temporal Dam and also the Jordan Valley. So the river was divided into 6 sections. The first section starts from the upstream until the slaughterhouse in Amman, and the second section started from the slaughterhouse to Ain Ghazal pumping station, wastewater pumping station, and the third section starts from Ain Ghazal pumping station to the yeast factory, and then the fourth section starts from the yeast factory to Awajan, and the fifth section is from Awajan, beginning of Awajan that goes through Zarqa city, beginning of Zarqa city to As-Samra wastewater treatment plant, and the last section starts from As-Samra to King Taral Dam. So the sources of pollution in each of this section were identified. The sections actually were identified based on land use, land cover, and anthropogenic activity in each section. So here this figure shows the actually in the basin along the river there are 4 wastewater treatment plants. The big one is, or the main one is, a Samra wastewater treatment plant, which treats about 90% of the wastewater generated in Amman city and also in Zarqa city. And there are another 3 wastewater treatment plants, minor. They are very something in the range of or in the order of 3,000 to 4,000 meter cube per day. So we have Jarash wastewater treatment plant, and we have Al-Baqa, and also we have Abu Nseer. But these are very minor as compared to Samra wastewater treatment plant. And also we have power generation stations along the or close to the river. And also we have landfills. We have 2 landfills, and also we have wastewater treatment. We have wastewater pumping stations. We have 2 wastewater pumping stations, which are too close to the river. We have one in Ain Ghazal, and we have one in West Zarqa. So the flood from these 2 wastewater pumping stations is also a major or a main source of pollution to the river. We have too many industries actually around or very or too close to the river. So these industries were identified, and we see that these industries are mainly distributed here between sections 3 and 4 in this area. So all these industries were identified and also classified. So we have, these are the categories. We have food industries. We have also slaughterhouse and slaughterhouse. We have many several, or many, not several actually, many marble industries. We have plastic, many also plastic industries, aluminum industries, cosmetics. We have a Pepsi pond and Pepsi factory. We have wood-based industries, also pharmaceutical, sponge industries, and we have also paper and cartoon industries. We have phosphate mines, these are abandoned phosphate mines, and we have chemical paints and detergents. So this table shows the pollutants in each industry category. These pollutants are actually based on literature. So these are the pollutants that come from each of these industries. And here we have the number of industries in the basin from each category. For example, we have wood-based industries about 9. And we have many marble industries of about 47. So we surveyed all these industries, counted them, and we know we are familiar with the pollutants released by these industries. And we also know the location of these industries along the river. Along the river also we have too many gas stations. And these gas stations can actually be leakage from these gas from the storage tanks for these gas stations can also be a source of pollution to the river. Now this is the Water Authority of Jordan and UMARCO monitoring programs. So the Water Authority of Jordan, they monitor these parameters, all these parameters, pH, TDS, TSS, and all these parameters. And also we have the frequency of sampling. Some are sampled monthly, and some parameters are analyzed every several months, every 3 months, for example. And also this is for UMARCO. UMARCO, they have 3 automated stations along Zarqa River. They have actually 13 automated stations along surface water courses in Jordan, 3 of which are located along Zarqa River. One station, which is station number 8, is downstream of As-Samra, wastewater effluent of As-Samra. And station number 10 is close to the Temporal Dam inlet. It's about 2 or 3 kilometers from the inlet. And station number 9 is somewhere in between. So the IMARCO monitoring station, they monitor TP, they monitor COD, temperature, turbidity, total nitrogen, EC, and pH. These parameters are monitored every hour. And the TN and TP, they are monitored every 6 hours. Yeah, so this shows the grab sampling, some information about the grab sampling program. So this shows the locations of the grab sampling and also the parameters analyzed. Actually, the grab sampling were mainly analyzed for heavy metals. We see here heavy metals, and some are analyzed for organics, depending on the location of the grab sampling. So pollution sources to the river, wastewater treatment plants, they are a main source of organics and nutrients, TP and nitrogen and phosphorus. Overflow of wastewater pumping stations. As I said, we have 2 wastewater pumping stations, which are one at Ain Ghazal and one at West Zarqa, and overflow from these 2 pumping stations is a main source of pollution to the river, because overflow is raw wastewater. So sometimes, or many occasions, raw wastewater can overflow from these 2 pumping stations to the river. Amman slaughterhouse is also a main source of pollution to the river. There is along the river in the Rusaita area, in I think section 3, there are sewer lines and manholes actually just within the river course. So these are also a main source of, let's say, again, raw wastewater to the river overflow or leakage from these sewer lines and manholes is a main source of pollution to the river. Industries, as I said, are also a main source of mainly heavy metals to the river. Commercial and domestic activities also are a main source of pollution to the river. Urban runoff is also a main source of heavy metals to the river. So these are the main sources of pollution to the river. So these are the main pollutants that reach the river from these sources: solid waste, organics and solids, nutrients, and heavy metals. So this figure shows the COD at IMARCO monitoring station number 10, which is too close to Temporal Dam. We see that now we had data, we had hourly data from January 2005 until December 2012. So this shows the now what's shown here is the monthly data, average of the daily data, hourly and daily data. So we see that the COD was down, and we see here a sharp reduction in the COD after 2007 or 2008, and that is actually due to the upgrade of a Samra wastewater treatment plant from a natural system to a mechanical system. So its efficiency was improved significantly, and consequently there was a sharp reduction in the organic ND load as indicated by the COD. Now these peaks, you see that there are some peaks here where the COD goes up too high, here and here. And actually there are several explanations for these peaks. They are coming, if they are actually within the rainy season, so they are coming from surface runoff from the adjacent farms, or they are also flushing some of the raw wastewater overflow from West Amman, from West Zarqa pumping station and from Ain Ghazal pumping station. So this, and also from the slaughterhouse. So this, these organics are flushed downstream. And so in some instances, if they occur during the summer, so they can be, sometimes there are some tankers, wastewater tankers, who sometimes they dump some waste or raw wastewater to the river. This shows also the TP and TN in the river at station number 10. Again, we see that there is a reducing the trend here between the after the year 2007 and 2008, and that is due to the upgrade of Samra wastewater treatment plant. And we see some peaks also, and these peaks are associated mainly with, can be associated with runoff from the adjacent farms and also from the upstream of the Zarqa River. Here we see a summary of all. These are all the heavy metals that are probably or that exist in the river, and these are the sources and the industrial sources of these heavy metals. For example, zinc comes from the marble industry, the fabric, the aluminum, paper. All these industries are a source of the zinc, and so on for the other parameters. This one shows the violations, spatial and temporal distribution of heavy metals, excedences in Zarqa River, and that's based on the sections within section 1, section 2, and up to section 6. Now the first 5 sections are upstream of Samra, and the other section 6 is downstream of Samra and also downstream of Temporal Dam. Now the NB means that the metal was detected, but it was not violated. Now here the W means that the element was violated, for example, once during winter. Or if here the S means that the parameter was violated 8 times during summer. So we see that, here this shows us the which parameters were violated and the frequency of violation, and also the whether that violation was during summer or during winter. And from this table, we see that most of the parameters or the violations occurred actually during winter, which means that they are associated with the runoff, either from actually heavy metals, other than the industries. The urban runoff is a main source of heavy metals also. Now this table shows the some statistical data about the samples, the number of samples, and also the location of the samples, whether they are upstream or downstream of Samra. These are actually for the heavy metals. For the water authority, this is for the Water Authority of Jordan samplings, and this is for the grad samples. So it shows the number of samples. Here, for example, we have 121 samples for boron. 68 were upstream of Samra, and so on. It shows also the number of excedences, also the special distribution of excedences, whether this occurred upstream or downstream of Samra. And here it shows the Jordanian standards for irrigation. So these are the Jordanian standards. So the violations are based on the Jordanian standards for irrigation. Now this table shows a summary of the special distribution of detected heavy metals, their industrial sources in every zone. So again, we have 6 sections. So here in each section, here are the heavy metals, and in each section, we see the what is the source or what is the possible source of pollution for this parameter in this section. Like for boron, for example, in section 1 CS, that's the cosmetic, the cosmetics. The PC is petrochemicals. So the 2 main sources of boron in section 1 are the cosmetics industry and also the petrochemicals. And these are the other sources for the other parameters in each section. Now for the river flow, we now know, who are familiar with the river, that the river is almost dry during summer, And this is because the over obstruction of the groundwater that underlies the river to satisfy the domestic needs, which cause the springs that feed the river to become dry. And this is actually the main reason why the river is dry. So the river is dry during the summer, and it also flows during winter after rainfall events. Now, downstream of As-Samra, the flow consists of As-Samra effluent during the summer mainly, and during winter it is a mixture of flood water and As-Samra effluent. So the main conclusions: the sources of pollution to the river have been identified. The sources of organics, sources of organics and the nutrients are the main sources of organics and nutrients. These are the As-Samra, Amman slaughterhouse, overflow from sewer lines, and also overflow from wastewater pumping station, also runoff along the river from agricultural, from farms along the river. Heavy metals along the river have been linked to their sources. Main sources of chemicals are industries and urban runoff. Zerger, after comparing with the quality with the Jordanian criteria for irrigation, so the river water is suitable for restricted irrigation upstream of the Temporal dam, which means that all the trees can be irrigated with this water, and also crops that are not eaten raw. Now, downstream of the Samra and the Temporal dam in the Jordan Valley, because the water is mixed with fresh water from Temporal dam, so the river water is suitable for unrestricted irrigation. Yeah, so this was actually this work was done within a project funded by the Scientific Research Support Fund in Jordan, and it lasted from 2013 or I think 2010 until 2014, and we have partners from the University of Jordan, Dr. Jawad Al-Bakri and Dr. Muna Hindiya, which was the director of the WAJ, the Water Authority of Jordan at that time. And also we have partners from the RSS, the Royal Scientific of Jordan, the Royal Scientific Society of Jordan. Yeah, thank you for your attention.
Thank you, Professor Abbas. In fact, we have like enough time would be after the last presentation from Engineer Azzam Al-Hamaidi. So there are some questions I think that directed to you, but these questions will be postponed after 10 minutes. We have now short presentation about a pilot projects was implemented in Jordan, and we have like one of our stakeholder, Engineer Azzam Al-Hamaidi. He will speak only 10 minutes, and then we'll have enough time because we have to finish at 7. So we have to have discussions, and I think that Surah will also, after the presentation of Azzam, will postpone the question, the evaluation for this workshop. I think that everyone needs to fill it, and if he needs also a certificate, so in the next few days a certificate will be issued for. So Engineer Azzam, please, you can start. Thank you again for this.
Yes. First of all, good evening, everyone. First of all, let me thank Dr. Ahmed Salaima and his team to give us this opportunity to present my project in front of you. Thank you for your time. And I have just 10 minutes. I will try to be faster as much as I can. Can you see my presentation from your screen?
Yeah, we can.
Yes, we do.
Yes.
Okay. Firstly, I'm gonna present myself and my company. I'm Azzam Hamaidi, the Director of Green Consulting Services at BDO Jordan. BDO Jordan is one of the international companies working in audits and advisory services. and we have more than 1,800 offices in more than 167 countries and all over the world. And we do a lot of services such as audit, tax, business services, advisory, management, consulting advisory, risk services, accounting services, training, and last but not least, green consulting services. Since I'm director of the green consulting services, just one slide about these services. We have 3 pillars. The first one is in environment and waste management, and we do a lot of service under this pillar. The second one is water management, and the third pillar is energy, renewable energy management.
Engineer Azam, excuse me. Can you put the show mode?
Sorry, I cannot hear you.
Can you put the
show?
Show mode.
إذا بدك بس بريس F5 مهندس عزام سلايد شو.
Yes.
Okay, thank you.
واضح هيك yes.
Yes.
سوري أنا ما انتبهتش لهذا كان وضحتوا لي بالأول. أوكي ما في مشكلة. Okay. Now I will jump to the presentation directly. Actually, there was a project funded by GAC, Global Affairs Canada, implemented by World Vision Jordan. This project, the aim of this project was to enhance the economic resilience of refugees communities and host communities under the name of NUR. And one of the objectives of this project is to install grey water systems powered by PV systems in 20 houses in 2 governorates, Zarqa and Erbit, in order to reduce the use of fresh water by using the treated water in irrigating their trees. The second point is achieve environmental benefits such as reduce greenhouse emissions. The third point is provide renewable source of energy. Because of that, they select 20 houses in 2 governorates, and they install these systems. I want to just highlight this small point. These houses that already selected, they have a green area around their houses, and they have cesspools instead of sewer system, because there's no sewer systems in the remote area. So one of the main criteria to select these houses that has cesspools. Okay. According to that, BDO was contracted by World Vision in order to do feasibility study and technical review for these installed systems. Because of that, we went there and we visited all these houses, and we checked all these systems technically and financially, in order to judge is it feasible, technically sound, and economically feasible or not. Actually, the systems were 2 types. The first one is horizontal, constructed wetland. The second one is vertical, and you know this terminology. And we checked all components. And now I will present the result and the main result of our study. After investigation and check all these systems, all vertical design of the grey water system were working well, while the horizontal design was have some problems, particularly with bad smell from time to time that disturbed the owner of the household. At the same time, the design itself was easy to operate without any technical issue. On the other hand, some of BOD and COD results was not comply with the standards. You know, Dr. Abbas Omar already mentioned some standards about the irrigate some plantation or trees or fruit or something like that in order to be used for households. some of the results were not complied with the standards. While the PV system, because already we checked the grey water systems and the PV system already linked together to power the systems, the PV system were working well, except one system with a technical issue. There's not a problem. And the household does not complain anyhow if, with technical operation problem about PV system. About the cost of grey water system, we tried to calculate all items of the systems, because already the system manufactured by a local manufacturer with small and simple tools, but the cost was around 1,400 GOD for each system, whether vertical or horizontal. About the PV systems, the cost was for 1 kilo peak around 750 GOD. You know, this result was in 2018. Now maybe it will be cheaper than this number. However, for small system, for example, 1 kilo peak or 2, it has to be higher than big systems. About the average of benefits, we try to calculate the benefits, not just feasible direct benefits, like cash, for example. We try to calculate the environmental benefits, social benefit with very complicated equation in order to come up with the real number. But after the calculation, we come up with two main categories. The first one, some houses already they do dislodging of wastewater. You know, some cesspools already they dislodging the water from time to time, but other cesspools they are not dislodging anyhow, because maybe the design of cesspools already infiltrate to the groundwater without earth without any dislodging. So we have two types. Houses already do dislodging, and this second one they did not do any dislodging. So by houses already they do dislodging, the benefit was around 330 GOD yearly, by the way. And the second type of houses without dislodging, the benefit was around 200 GOD. So, but you know that the benefit is vary from house to house, while the reflect of economic feasibility of this system maybe will be changed from house to house. The next point is payback period. Already we calculate the payback period for grey water systems. With dislodging, the payback period was without dislodging, without dislodging, the payback period was 12 years. While the houses already do the dislodging, the payback period is around 60 years. So, but you know, the water tariff, if any changing with water tariff will the payback period will be positively affected. Now I came up with the final slide about recommendation and the final results. In installing the grey water system with an subsidized water tariff in Jordan is not economically feasible, particularly in the subsidized tariff and poor people surrounding the governorates. The second point is the owner of household were willing to have PV system in their houses without any support, without any donor agencies in their by their own. While the grey water system, they are not willing to have it because some technical issue and payback period is very long, and they don't have the effort to do for grey water system in their houses. And we do some market research about enhanced in order to increase and convince people to have gray water system in their houses. But according to our results, was market or upscaling such systems. It's not acceptable for their own without any support or fund or support from governments. So we need some support from government in order to enhance them or convince them to have such systems. So according to that, we need more effort to enhance the design in Jordan, particularly in the rural area. And we need some fund to use gray water systems in our houses. Last but not least, cooperate and partnership with NGOs and government agencies. This was our results in this project in 20 houses and 2 governorates. I know this result is not happy for some of you, because we try to increase and promote such activities and ideas to use gray water system, but we have to be practical and to put some more effort for design and support and awareness in order to reach successful results. Thank you very much for you.
Thank you, Engineer Azzam. It was a very good presentation. In fact, now we have like 15 minutes for questions for all participants, maybe for all presenters, sorry, for Professor Abbas, for Dr. Barbara and Dr. Fabio, also for Engineer Azzam. Unfortunately, Professor Radwan, he left to his master thesis defense. However, before we leave, I have a request from Barbara that she needs to make like a group photo. If everyone can open the camera, maybe after we finish maybe the question sessions. So anyone has a question, so please raise his hand or introduce himself and direct the questions to the presenter.
There is a question on the chat for this last presentation from Mohammad Faris. What was the technology used for the green? Yes, for the green water treatment, the gray water treatment.
So this is a question to Engineer Azzam.
Sorry.
The last speaker. Can you ask again?
For me, already I presented that we have 2 designs, the horizontal and vertical wetland. This was our design, their design, because we didn't install the design. We checked the design. We didn't install it.
I have a question too, and well, very nice presentation, and both the designs can work very fine, the horizontal and the vertical. My question is, what is the main cause of the need of public funding for having a wide adoption of household grey water treatment systems? Is the low cost of the water from the tap? Because, for instance, in Germany, there is a very brilliant market exploitation of for the grey water treatment, because they pay the water €4 per cubic meter. Here in Italy, we pay €1 per cubic meter, and it's quite hard to convince a family to invest, I don't know, 1,000 euro all in a shot, for then recovering in a payback time like 15 years or 20 years. And then that's a too long period for making the thing appealing on the market. Is that the same reason you have in Jordan, or do you have other reasons?
Yes, if you allow me, the main reasons are, first point is water tariff, because water tariff is subsidized, particularly with the first and the second category, because the first category 20 piaster, like almost $0.3 for 1 cubic meter. Then after that will become higher, 0.4, and then 0.6. Then after that, $1, etc. So if we target the rural area and poor people that already consume, it's not a lot of water, a small portion of water, the category will be the first or the second. So they are paying a very small tariff. This is the first point. The second one is the characteristic of water, because already they use a small portion of water. That means the construction, the characteristic of water will be higher than normal. For example, full of oil, some detergent, etc. That will affect the design itself and will block and will come with a bad smell, etc. It's not normal, for example, in big cities or in Europe or etc. This is the second point. The third point is the cost of the system itself. It's very higher if we compare it with the payback period, etc. So the main reason behind unsuccessful results.
Other questions to any of the speakers? So please, if you have any question, you can go ahead directly, because before we conclude our workshop.
There is another one in the chat.
Yeah, there are two questions on the chat, and about this last question and answer, the project was similar to what we developed in SWMed project. There was a comparison between the industrial and the constructed wetland at domestic level in different areas, and so if you want to also check, you can ask for the results and the final report of SWMed project, where we try to understand also the economic feasibility and social acceptance of this kind of solution. That actually, yes, it's a problem to solve, but for this reason, for example, working with the building code and also try to create some incentive to invest in this kind of solution can be a possibility.
That the reply for
yes, continue, Barbara. Yes, please.
Yeah, the reply for Hamadi about the footprint of nature-based solutions for greywater treatment. If we refer to vertical or horizontal constructed wetlands on the ground or even on the roof, we can assume in Mediterranean climate, let's say 1 square meter per person in terms of footprint. That's demonstrated to be enough for reaching quality, good for the reuse for toilet flushing. Then everything is related to how much we want this water clean for more noble usages, like for instance, for entering in the food chain, as we were discussing in the chat, which is related to the presence of micropollutants inside. And mainly we still don't know, because those are parameters quite difficult to be monitored, especially in quantitative terms. And therefore there is still few research done on the topic for being sure that we are not creating any bioaccumulation in the food chain if we make use of gray water constantly for growing lettuce, for instance.
Can I have a question?
Yes, please.
I have a small question for Fabio. Is there any fruit or vegetable in the proposed plantation?
Yeah, I replied in the chat, and
sorry, I didn't check it.
Yeah, okay. For the moment, we decided to not go in that direction, even though we were very tempted, because this reuse of water and production of food is nowadays a very trendy topic. There are a lot of projects funded by the European community exactly on this topic. And there are some of our competitors, like an Austrian company, which is proposing to use green walls for treating black water and growing food at block level. And for us, it's still quite hazardous. I mean, the scientific knowledge is not still giving us a safe chance to go in that direction. And that's why still in the gray water, you have some products, personal care products mainly, toothpaste and so on, which are releasing small quantities of persistent organic pollutants. And we have to be sure that those are removed in the biofilter that we are using. And still nobody have make a nice analysis with nice frequency and so on for being sure about this removal. We hope that they are removed because the organics are binding very well in a reactor which is mainly organic, and therefore probably they are retained there, but still we have to be sure. And therefore, for the moment, it's just ornamental plants, and we don't touch the water-food nexus.
Okay.
I forgot just to mention one point, because I'm my honor to present my presentation in front of my supervisor, Dr. Abbas Omari, because was my supervisor.
Yeah, you did. Yeah, very good presentation. And you have made a very good progress in your profession since you graduated. Too long.
So thank you. Yes, Professor Abbas.
Yeah, there is a question here. Are there aquifer recharge with the treated wastewater at Samra? Actually, there is no Samra treated water is not used for groundwater recharge. It all flows to the Zarqa River and it goes to downstream to the Jordan Valley, mixed with the fresh water and used for irrigation. There's no groundwater recharge with Samra.
Okay, thank you, Professor Abbas. I think that now we are coming to the end of this workshop. Please give me 1 minute to conclude that we promise you that we'll have like a series of workshops in cooperation with Jordan Engineers Association. We would like to thank Mr. Ibrahim and also the civil engineering sections. However, Engineer Sura also posted the evaluation form for this workshop, so please don't hesitate to fill it. And also a certificate about participation in this workshop will be sent to you by the email within 1 week. However, according to the wish of Barbara, she needs to take like a group photo for all of us if we can open the camera and before we end our session. So this is Barbara that you need, yes?
Yes, thank you. So we can promote this event with a news. And it's great to have people because the projects are made by people, not but just by words. It's good sometimes to show the people that are behind the theories. So if you can, yes, open the camera and we take a picture all together. Also because we are a lot, so it's good to show.
دكتور احمد الحمد لله على سلامتك، يعني صورتك يعني معبره.
تسلم ان شاء الله، الله يخليك، تسلم ان شاء الله.
الحمد لله على السلامه ابو صهيب.
الله يسلمك، الله يسلمك يا دكتور.
لا بأس عليك.
الله يخليك، تسلم إن شاء الله.
Okay, Barbara.
Did you
yes.
finish?
Okay, I took one.
دكتور أحمد ليش أنت؟ دكتور أحمد مرحبا، مساء الخير.
أهلا دكتور عبير، كيف حالك؟
شو صار لك؟ المفروض أنت هناك، لا المفروض أنا محلك في المستشفى، ليش أنت هناك؟
شكلهم ضربوني عيني يا دكتورة.
لا 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 لا. ألف ألف سلامة.
والله
ما بعرف إنه مالك إشي.
والله سويت قبل شوي قسطرة والله.
سلامات سلامات، بسيطة إن شاء الله.
الله يسلمك يا دكتور، الله يخليك، تسلم. يعني بنشكركم جميعا يعني على مشاركتكم، وإن شاء الله يعني بنضل متواصلين معكم، وإن شاء الله في ورشات أخرى إن شاء الله المستقبلية، والله يعطيكم ألف عافية جميعا إن شاء الله.
الله يعطيكم العافية. السلام عليكم.
يعطيكم ألف عافية. السلام عليكم. سلام. أهلين.
مع السلامة.
Thank you. Bye bye to all, everybody.
Bye bye.
Take care, Ahmed, and thank you, Shura.
Get well soon.
Thank you, Barbara.
Take care, Ahmed. Stay safe.
Thank you, Fabio.
Bye.
Bye bye. Bye, Farah.